Welcome back to a new video. In this video, we are going to create a data science project. We are going to start from data analysis, we will do feature engineering, we will train machine learning models, and then we are going to create a Streamlit Web App. Our dataset is going to be about restaurants' ratings, and we are going to try to predict the restaurant rating with features it has. And I'm going to be adding its link in the description of this video. So let's start coding. So here we are in the VS Code. Now here is our dataset. I'm going to create an IPMB file like notebook.ipmb, and then we are going to analyze our dataset and train our model in here. Then we are going to create a Python script and a web app using Streamlit. Great. So we can directly start by selecting a kernel at the first place. And then I'm going to say import pandas as pd, import matplotlib.pyplot as plt, import seaborn as sns, and then what we are going to do is we are going to set something like data, and actually let's set like df, and it's going to be pd read csv and our dataset.csv, and then we can directly call our data frame and check how it looks. So we can see that we have a lot of columns like restaurant ID, restaurant name, country code, city, address, locality variables. We can directly do data frame.info and get information like the column names, data types, non-null count, data types in here too, memory usage. Great, so there's a lot to do. Now we are going to do something like we can just say data frame.describe, and we can get the summary, numerical summary of the columns which has the data type integer and float. Like when I call this, we can see that at the restaurant ID we don't care about this, country code we don't care about this. We can care about the average cost for 2. Let's see the mean on that. The mean is 1200, and we can see the standard deviation is like that. So it's centrally distributed, we can guess. The minimum is 0, and the maximum is this 800,000, and we can see the quartiles. So I think this is an outlier, maybe not, because it can be so luxury thing. And we can see the price range in here. Also we have average rating. The average rating mean is 2.66, so I guess it's from 1 to 5, and actually it's from 0. It's starting from 0. I can see from here. So the average, if we say 2.5, the average is above that, but it's pretty close to 2.5. And the votes in here is the votes count. Like the average count for the votes is 156, and we can see that we have a high standard deviation, so compared to the mean, because someone get 10,000 votes, so it makes sense. Great. So we can directly move to checking the duplicates and the NA values. So let's start with duplicates. I'm going to say data frame.duplicated.sum for checking duplicates. And we are going to see that we don't have any. Great. So we can directly check the null values. I'm going to say data frame is NA. If I call like that, we are going to get a Boolean indexed data frame. And if I do sum, we are going to see the column wise NA values. We don't have any. Great again. So everything seems great. We can start to our analysis. I'm going to call the column names again for remembering it. And now we can start by grouping by city and calculate the average cost for 2. So I will say data frame. Actually, we can write what we are going to do. Group by city and calculate average cost. In this way, I'm going to write the code after it, and I think it's going to make more sense. So I'm going to say data frame group by, I will say city, and I will say average cost for 2, and I will take the mean of this like that. So there is a column not found error. Let me quickly check what's the actual name. Average cost for 2. The lowercase t is going to be it. And great, here it is. So we can see that actually I'm surprised. We have Istanbul 2. It's a city from Turkey. And now we have an array with the length of the 141. It's pandas series. We can manipulate it easily. Like I can say sort values ascending false, and then we are going to get the most expensive ones like the Jakarta, Leeds, Tangerang, Bogor, Pasay City, etc. We can say ascending true like this, and the Miller is 0 actually. Dickey Beach, Inverloch, Lakes Entrance, Lakeview. So since this is a panda series, let's say that you want to create a plot with the first 5. What you can do is you can set this to false. I'm going to go step by step. Then I'm going to say dot head for getting the top 5. And here they are. Now I will say dot plot, and I'm going to set the kind as bar like this. And when I create this, you are going to see that we are going to have a bar plot, and we can upgrade it. Like I can add a title to this. So let's do that. plt.title city wise, actually average cost for 2 per city, top 5. And then we can say X label is going to be city, and we can say for Y label it's going to be the amount, and we can just say plt.show, because if we don't say, we are going to get this thing. Like I'm going to show you like this. You can see that we have this in here. If we use plt.show, we won't have that. Great. Also what we can do is we can add a grid to this, like plt.grid, just like this, and we will have the grids in here. Great. I generally prefer grids, but in a bar plot like this simple, I'm not going to prefer it. I think it's meaningless, so I'm just going to delete it, and it looks great. Okay, let's group our data by cuisines and calculate the total number of votes. So what we can do is we can just say cuisines and total number of votes. Now we can say data frame dot group by cuisines, and then we will say votes dot sum. At the first place, what you are going to do is you are going to give the column name that you want to group by, and at the second place you are going to give the column that you want to get the values of, and you will give the aggregation function like this. It's the structure of the group by code in Python. So when I do that, we can see that it's the cheapest one is the Afghani and world cuisine patisserie. At the end, I'm not going to be sure about it's the highest, because I said Afghani is the cheapest because it says 0 in here. And what we are going to do is we are going to just do sort values ascending false for seeing the top ones, and ascending true for seeing the lowest ones. I'm not sure why did they enter these like 0, but I think it's okay. So it's not Afghani, there's a lot of entries, like we can see Bengali cheese, Italian, fast food. So what if we want to see the zeros? We can do, actually, let's do like get the zeros at the first place, and then let's remove the zeros. So at the first place, what we are going to do is I'm just going to take this group by in here like this, and I'm going to get this as a data frame. So what I'm going to do is I'm going to say reset index, and when I do that, we are going to see that it's going to be such like that, cuisines, votes, and it's going to be a data frame. So I'm going to set this like, let's say data, and we will see our data is going to be something like this. And now we can just filter it out. Like what we can do is we can say data votes, and actually I was thinking prices, so that's why I said like the cheapest, but I just saw that we grouped by the votes. I remember it like that. So the vote count doesn't matter, and we can say cheap or expensive, that side of things. Okay, so I just misremembered it. We can just get the votes equals to 0, and we can filter the 0 ones. Like here are the ones that are voted 0. So at the next place, if we don't want them in our data frame in this way, we can just do this, and we get the only non-zero ones. Great. So we group by the votes, and there is no such thing as prices in here. Great. I'm showing all of this because I'm trying to show the data manipulation on the group bys. And now we can move on. Great. So let's create a pair plot for some columns for checking the correlations. Like we are going to create multiple graphs and see if they are changing with other column. Like they are going to be scatter plots. So what we'll do is we are going to say sns.pairplot, and then I'm going to give the data frame with two brackets like this because I want to pass the entire columns. I will say average cost for two and aggregate rating, and actually I think are the lowercase. I'm going to just check it by data frame columns like this, and yeah, it's correct. The R is lowercase, and then I'm going to just give the votes like this, and then we can just see our result in few seconds. So here it is. Actually, I'm going to look for the average cost for two and average rating at the first place. From here we can see that the most average cost for two values are at the left side, so the most of them is lower than the sum of them. So we can see that at the right, when we go to right, the ratings increasing, like the highest prices are actually the ones that is getting better ratings, and at the left side we have zeros and twos a lot. And at the vote size we can see that the low price ones gets voted, and when the average cost increases, like the right side, the vote count is decreasing. Okay, we can also check the aggregate rating and votes. We can see that it's crowded at the bottom side, and when we go to the left at the rating side, we can see that some of the votes got upside, like some people voted 5. We can see that. Great. Okay, so I'm going to call the data frame.columns again for checking what we can do in here. And let's see, I'm going to re-record when I think something. We can get the count of the restaurants offering online delivery. Like what we can do is I'm going to say data frame has online delivery, and I will say value counts. So we have mostly no. We can also create a chart from this, like I will say plot kind pie like this, and we can see no, yes. We can just do plt.title has online delivery, and then we can say, actually I don't want this count in here. I'm going to make it rerun. I want you to see that. If you want to remove this count in here, what you can do is you can just say plt y label, and you can pass an empty string in here. So it's going to disappear right now. Great. And then I will say plt.show. Also I can add something like plt.legend to this. Like you are going to see that we are going to have a legend in here too. Great. So now I'm going to do something like, I will firstly call the rating text column, and then I'm going to say .head, so you can see how it looks. We have excellent, very good, excellent. So I think that actually let's get something like data frame, both rating test and rating. Actually, I don't remember the exact name. Aggregate rating in here. Aggregate rating, the lowercase, and then rating text, the second bracket. Now it's going to work smoothly. I think if it's above 4.5, it says excellent. If it's above 4, it says very good. Let's check more. Head 10. It says, actually, let's go to the tail. We don't have any different examples in here. Actually, we don't have two in here. So what we can do is we can just say data frame sort values, and then we are going to say something like by aggregate rating, and let's set the ascending as true, and let's see what we are going to get. Great. So 0 is not rated. Then I'm going to say like head and 200 like this, and we are going to see that we still have not rated ones. 500, okay, 1000. Actually, let's increase the number, like 2000. No, we don't have any in here. 5000. Also, I want to say that I'm going to remove this not rated ones when we go to the modeling side. Okay, now we have the above 3 is average, great. Let's say 6000 and 7000. Above 3.5 is good. Okay, we got all of the grades we have. Nice. So I guess above 2.5 is like average. Also, we can check that too. Like from here, I can say head 4000, and 3.0 is average, 3000. And this is average too. Okay. And let's see if we have any below average. Like we can just filter it like this. And 400. Actually, there's better ways to do it, but I just prefer this. Like we can see below 2.4 is poor. Okay, so we have the values we want. So before moving to the next step, what I'm going to do is I'm just going to call the data frame, and here what I want to do is I'm going to filter the data frame by the rating text, and I only want to get the values that is not equal to not rated ones. So I'm just going to make it run, and I'm going to set as data frame. So when we do that like this, and when we call the data frame and rating text dot value counts, you are going to see that we don't have any not rated ones since we filtered them out in here. So let's create a pie chart from this information. I'm going to say plot, and kind is going to be equal to the pie like this. And here is our pie chart. Also, we can just do the special things like title, rating, average, and we can say plt.y label, it's going to be empty, and we can say plt.show, and here it is. Great. Now we can start the modeling. So at the first place, we are going to take some columns for the x and y. We are not going to include everything in the x, and we are going to take some features like 4 or 5 that we think it can affect the rating. So our target is going to be rating, and now what we can do is we can just say, like, I'm going to say data frame.columns for seeing them. Actually, we can go with filtering. So at the x side, what I'm going to do is I'm going to filter it like, actually at the x we can include average cost for 2 for sure. It's a sure thing. Like I'm going to take it in here, and then I'm going to say currency is not important. Has table booking can be effective because I want a restaurant to has table booking, so I'm going to take that. So I think like there's like some people like go to the restaurant and try to do table booking, and if it's not happening, they can instantly go to the rating app or whatever they use, and they can rate bad just because they didn't book without having a meal. So that's why I'm going to put the has table booking and has online delivery. So I will say has table booking, and then I'm going to say has online delivery. Great. So next step is going to be the price range. I'm also going to include that for sure, like this. And then I think it's enough. So I'm just going to make it run, and it's going to be our x. At the y side, what I'm going to do is I'm going to say something like, actually I'm going to take the rating text in here, and then I'm going to encode them like 1, 2, 3, 4, 5 text wise, or we can directly go for a regression. We can just try to predict the aggregate rating, and then from the aggregate rating we can do like, we can convert the coming aggregate rating. Like let's note it down, like if it's above 2 and below 2.5, I remember it like poor, and I remember it like it's above 2.5 and it's below 3.5. It was something like, I don't remember. Actually, it was like average, I guess. Above 3.5 and below 4.0 is good, and above 4 and below 4.5 is very good, and above 4.5 is, I remember it like excellent. So with considering them, we can create a Streamlit app which is going to show the results like this. So what I'm going to do is I'm going to take the aggregate rating. So I'm going to just paste this aggregate rating. I'm going to take this and paste this in a notebook, and I'm going to use them later on. Okay, so let's just fix this aggregate like this and then keep going. So at the next step, I'm just going to call the X, and we are going to do some data transformation operations in here. Like what we are going to do is I'm just going to start by changing them into numeric values, like we are going to do encoding in here, and then I'm going to scale this X since there's different ranges in here. Like you can see that we at the price range side we have 2, 3, 4, 2, and at the average cost side we can see that there is add of different values. Like I firstly want to check the price range, the values it takes, like value counts in here, and I'm going to just see like it takes values between 1 and 4. I guess 1 is the cheapest and 4 is the most expensive one. So at the price range side we are going to take input 1, 2, 3, 4. Okay, so let's keep going with calling the X, and then I'm going to import like from scikit-learn import preprocessing, and then I'm going to use label encoder. Like label encoder, we are going to initialize it like preprocessing that label encoder, and I will say like I'm going to come to my data, X has table booking, and I will say like fit, actually it's going to be label encoder fit transform data and has table booking, such like that. So actually there's a here, let me quickly check, has table booking. Actually I need to call the X instead of data, so it's going to be fixed right now. So when we call the has table booking right now, since we set it like this with an equal sign, we are going to see numeric values. So 1, 1, 1, 0, 1. So there's two ways to understand which one is 1 and which one is 0, like which of the yes or no belongs to 1. So at the first place we can check the first index in here. Index number 0 is 1 and index number 0 was yes. So we can directly say that 0 is yes. I'm sorry, 1 is yes. So 1 is yes. And at the third, fourth index, with the index number 3, we can see that it's no, and we can come to here, it's 0. So we can say that like has table booking, 0 is no, 1 is yes. This is an option. Also what you can do is in here you can directly say like label encoder, and you can say classes like this, and you can see that no and yes returns. So no returns at the first place means that no has the index 0. So this array means that the index 0 is no, so it encoded the no with 0, and it says yes at the first index with the index number 1. So 1 is yes, as you can see. These are the two methods that you can do this operation. I generally prefer classes because if you have more than, let's say, 5 or 10 classes in your data, it's going to be hard to consider which one is matched with the number. So if you do classes, it's going to return you an array like this, and you can directly from this array select the 0 for getting the no and select the 1 for getting the yes, and understand it like that. So now we are going to do the same operation for the has online delivery. So I will say X and has online delivery. I'm going to say X label encoder fit transform, and I'm going to take has online delivery from here, has online delivery, like this. And then actually there's a problem, let me quickly check it. Okay, we will say like this, and I'm going to call the X in here, it was a mistake, like this. So in this scenario it's going to work out smoothly, and when we call the X, we are going to see that we have integers in here. Great. So again, I'm just going to use the second step. I will say label encoder dot classes and check, like no at the first place, yes at the second place. So I will say again has online delivery, and in here what I'm going to say is 0 is no and 1 is yes. Great. So I'm just going to take this to my notes too for the Streamlit side, and now we are going to do the scaling. So I will say like from scikit-learn the pre-processing import standard scaler, and I'm going to initialize it like scaler is going to be equal to the standard scaler, like this. And then I will say scaled X. Actually before this, actually let's do like scale of them. Let's say like X is going to be from now on scalar that fit transform X, like this. And then when we call the X, we are going to get the scaled values like this. Okay, great. I was thinking like scaling after the train test split. It's an option, I'm not going to do that. Maybe it's the proper way, but we are going to continue like that. Now what I'm going to do is I'm going to say from scikit-learn we are going to do train test split model selection import train test split. So why we do train test split? We are going to have two parts, training data and testing data, and we are going to train our models with training data, and then we are going to test our models with the test data, because we are going to see the models how they are performing on the unseen data, and we are going to evaluate them with the test data. So for that we are going to say X train, X test, Y train, and Y test, and we will call the train test split X, Y, and let's set the test size as 0.2, which means that 20% of the data we have in here is going to be in the test set, and the 80% is going to be on the training set. Okay, now we are going to continue with the modeling side. At the modeling side, firstly I'm going to define a function for getting the model results, so we don't call the mean squared error etc every time. So we are going to start by that. I will say something like from scikit-learn.matrix import mean absolute error and mean squared error, and then I'm going to import numpy as MP, since we are going to square root of the mean squared error. And then I'm going to set something like define model results, and I will give the predictions like this, and then I will say print mean absolute error on model is like this. Then I will use format, and I will say mean absolute error, and actually mean absolute error. Then I'm going to say Y test and the predictions. The predictions are going to be the ones that we are going to pass into this function when we get the models and when we get the predictions using the X test. So here is our mean absolute error side. We need another parenthesis like this, and now it's going to work smoothly. Then I will say print root mean squared error on model is, and then I will use dot format again. I will use numpy the square root mean squared error like this, and I will say Y test and predictions just like that. Okay, great. Our function is ready right now. So we can start with linear regression. So for that, what we are going to do is I will say from scikit-learn.linear model import linear regression, and then I'm going to set LR as linear regression. I'm going to initialize it like that. Now I'm going to train my model using linear regression.fit, xtrain, and ytrain. And after that, what we are going to do is I'm going to say linear regression.predict, and we will just predict the x-test. So when I call that, we're going to get an array like this, and I'm going to set this something like predictions from linear regression. And then I'm going to call my function, and I'm going to give model results. I'm going to give predictions from linear regression, and we can see our mean absolute error and root mean squared error. So great. Again, the predictions from linear regression is the predicted values we have, like the predicted ratings, and here is our error values. So let's continue with other models. So let's go with support vector regressor. So we will say from scikit-learn.support vector machines import SVR. And what we are going to do in here is we are going to do also grid search for finding the optimum parameters for getting the best model possible. So we will say from scikit-learn.model selection import grid search cross-validation. And after importing that, the next step is going to be initializing the model that we are going to use. I will say SVR model is going to be equal to the SVR, and then I'm going to say parameters grid SVR is going to be like C, just like in this one. Also, you can see these parameters, what they do, how they change the model performance by the specific videos on my channel, like specific ones that I record for the support vector machines or other models. I record separate videos for them. I think I have the most. You can also check my scikit-learn course. It's a 1 hour free course. You can also check that. We are going to give C as a parameter, like it can take values 0.001, 0.01, 0.1, and 0.5. And then what we can do is we can give kernel, and it can be like linear, RBF, and poly. And we can give degree, like just like that, degree, and it can take, let's say 2, 3, 4. Okay, great. These are going to be our parameters. So actually I think it's okay. So let's see, there's a problem. Let me quickly check what's wrong. So we open the dictionary, and I think we have the problem in here. So let me quickly fix that. It says there's an error in this side. So I think it's going to work smoothly right now. Great. We have our dictionary in here. And then the next step is going to be grid SVR. We are going to initialize the grid search, like grid search cross-validation, and we will say SVR model. Then we will say parameters grid SVR, like this. And then the next step is going to be grid SVR dot fit. We are going to train our model using xtrain and ytrain, like this. And we can also use warnings, ignore, but I'm not going to do that. I'm going to come back again when this is trained. So what this is doing in the background is it's trying every combination in here, like it takes one from the C, it takes one from the kernel, it takes one from the degree side, like 0.01 linear and 2, and then 0.01 RBF to 0.1 linear 2, and then it gets to the 3 for an RBF poly. So that's why it takes a little bit. But for the next models, I'm not going to include this much options to the parameters, and I'm going to be coming back when this trains. You can extend this list as you wish, like you can add 5, 6, or you can lower these numbers. It's up to you, but I'm not going to do that from now on because I don't want it to take too much time. So it's taking forever. That's why I'm going to stop it. Like I'm going to interrupt the kernel like that. And when it finishes, what I'm going to do, I'm going to decrease the number of these parameters. Like there's going to be, actually I'm going to say restart. I'm going to say run all, actually not the last one. So I'm just going to do something like that. And what I'm going to do is actually I'm going to decrease the number of parameters, like let's left 2 in here, and let's left 1 in here, and like let's left actually leaving 2 in here is going to be better, and let's leave 2 in here, also let's leave 1 in here. So let's go like that, otherwise it's not going to end, and I'm going to make it rerun, and then when it runs I'm going to be in here. So okay, we have our model trained in 7 seconds. You can extend these parameters, but I'm not going to do. You can do that. Okay, after finishing this, what I'm going to do is I'm going to come to here and I'm going to say grid_svr.predict, and I will give the x test like this, and we are going to get an array again like this. So now what we are going to do is we are going to store this into something like predictions grid_svr, and we will say set this, and we are going to call our model results function, and I will say preds grid_svr. So our results are in here. Great. So let's quickly compare them with linear regression. Okay, nice. And they performed like same. Okay, I'm just going to recheck, and I think it performed a little bit better. Okay, so at the next step I'm going to train a tree model, decision tree regressor. So for that I'm going to say from scikit-learn.tree import decision tree classifier, actually not classifier, regressor. And at the next step I'm going to define the parameters for this. I will say parameters grid, and it's going to be like, we can give criterion, but actually let's not give that. We are going to decrease the parameter amount, so I will say like max depth, and let's give max depth like 10 and 30, 2 options, and then I'm going to give like minimum samples leaf, we can give 1, 2, and then let's give min samples split, and let's give like 2 and 5 again. So after that I'm going to initialize it like tree model is going to be decision tree regressor, and then I will say grid tree is going to be grid search cross validation, estimator is going to be tree model like this, and parameter grid is going to be like parameter grid like this. Okay, now what we are going to do is we are going to train our model like grid tree and fit X train and Y train. Great. When this is training, I was going to say something, but it trained in a second. You can also give some options like cross validation in here. I'm not going to do that. You can extend its features, and after fitting this model we are going to get predictions from here like grid tree.predict x test like this, and now we are going to store it like 3 predictions, and let's do model results 3 predictions after that. Great. By far this was the best performing model. So if you are going to develop a Streamlit app, for now we are going to use this model. Okay, let's try another tree based model, random forest regressor. So for that I'm going to say from scikit-learn.ensemble import random forest regressor. And then I'm going to say RFR model is going to be random forest regressor, and I'm going to set parameters grid RFR as we can give max depth, and I'm just going to give 5 and 15, and we can give like number of estimators, and I will give like 2, 5 and 10. I can also give some stuff like maximum features or bootstrap, but I'm not going to do that. Again, I'm going to say grid RFR is going to be equal to the grid search cross validation. I will say RFR model, and I will say parameters grid RFR. You can also specify them like param grid and estimator, but there's no need because it understands it. And then I'm going to say grid RFR, I'm going to say fit, I will give the X train and Y train, and it's going to train a second, I guess. Yeah, great. So now we are going to get the predictions like random forest predictions is going to be grid RFR dot predict x test. So I'm going to get model results in here like predictions. Actually it's random forest predictions, and it's performed same with the decision tree model. We can take either one of them. Tree based models performed good on our data. By the way, I want to mention one thing, that in tree based models you don't need to scale your data. Like there's no need for that. You can also scale, it's okay, but you don't need to scale. Okay, when we have this, actually I want to show you another thing. Like we are passing a lot of parameters in these models. Like you can check, we gave like 2 for max step, 3 for the number of estimators. What if you want to see the best performing parameters? And then you can call the grid search, then you can say best parameters like this, and you are going to see 5 for the max depth and 10 for the number of estimators is picked as best performing parameters. You can do that all in the grid search models. Like I remember tree model, like you can call best, actually I don't remember the exact name, the grid search version of the tree model. Like let me quick check. Grid tree, okay. You can say grid tree dot best parameters like this, and max step is 10 on that side, minimum samples leaf is 2, and minimum samples split is 2 on the tree side. Great. Okay, let's train AdaBoost regressor. So for that I will say from scikit-learn.ensemble. Actually we did out of tree based. I'm just going to move to the, let's try k-neighbors regressor. I'm going to say from scikit-learn.neighbors import k-neighbors regressor, and then I'm going to set knn as k-neighbors regressor. I'm going to give it a parameter grid like knn param grid is going to be one parameter, number of neighbors, and I'm going to give 3, 5, 7, 9, and then I'm going to do knn grid search is going to be grid search cross validation. I will say knn and knn parameters grid, and then I'm going to do something like knn grid search dot fit, and I will say x train and y train. So I'm going to say something like after this knn predictions, and it's going to be knn grid search. Then I'm going to say predict, and I will give the x test like this, and we can get the model results for knn preds just like that. And we can see that it didn't perform better than the tree based models. So let's check the best parameter for that. Best parameters, actually we will do that on knn grid search like this, and it's going to work smoothly. The picked number of neighbors as 9. So what you can do for increasing this model performances, you see that it picked the biggest one in the parameter grid, so you can just delete the before ones and you can just extend this like just like this, since you know the big numbers working better. So I'm just going to make this rerun in here, and let's see, it performed better and it picked 15. So you can increase these numbers if you see 9 is picked in the before list, but since it picked 15, what you can do is you can just do 16 in here, 14 in here, and you can retry to see if it's going to pick another one. Like it still picks the 15, so 15 is the best performing one. So why I skipped AdaBoost is it's not a tree based models, but I want to try a different thing. Now we can do the AdaBoost. After doing 2 tree based models, I didn't want to do on the boosting side since I did the random forest. So now we can do, I'm going to say from scikit-learn.ensemble import AdaBoost regressor like this, and then I'm going to set the Ada as AdaBoost regressor. Then I'm going to say Ada parameters grid is going to be number of estimators. Let's give 50, 100 and 200, and let's set learning rate like 0.1, 0.5 and then 1. Okay, let's not increase that. and then I'm going to say ADA grid search is going to be grid search cross validation. Then I'm going to say ADA and ADA parameters grid. Okay, now we can train our ADA boost model like ADA grid search dot fit x train and y train. So after this, when it's trained, I'm going to be in here. Okay, let's see our results. I'm going to say ADA predictions is going to be ADA grid search dot predict, and we will give the X test. And then what I'm going to do is I'm going to say model results, and I will give the ADA preds like this. Okay, great. So I think it's more than enough at the modeling side. We can try other models, but I'm not going to do that. I'm going to take the grid RFR, this model. Like I'm going to take this, and then I'm going to create my Streamlit app using this. So again, what I'm going to do is I'm going to export this model, and then I'm going to create a Streamlit app. I'm going to say import joblib, and then I'm going to say joblib dump, and I will give the model firstly, like let's say grid RFR, and then I'm going to say ML model, machine learning model dot pickle, like this. I'm going to make it run, and we can see that it's in here. Great. So we can jump to the app.py, the script that we are going to create for the Streamlit app. Great. So in here, we are going to go step by step, and let's just close this, and I'm going to start coding. So as the first thing, we are going to import Streamlit, and we are going to import, actually I'm going to import NumPy, and then I'm going to import, I'm not sure I'm going to use NumPy by the way. I'm going to say from scikit-learn import standard scaler, since we are going to do scaling. Actually, let me remember, it's importing code. I'm just going to check it from here how I imported it, and I imported it like from scikit-learn.preprocessing. So I'm going to take that like that, and then what I'm going to do is I'm going to say import joblib. At the first side, I think it's going to be enough, and then at the first place, because I don't want to forget it, I will say scaler is going to be standard scaler, and I will do the scaling later on. What I'm going to do is I'm going to say streamlit.title, and I'm going to give the title like, actually we need to import the streamlit as st, then streamlit title, we can say like restaurant rating prediction app. And then I generally do this when I'm creating a Streamlit app. I will say streamlit.set page configuration layout is going to be wide. I do this every time when I create a Streamlit app because I want my app to be in the wide layout. Okay, at the next step, what we are going to do is I'm going to say in here, I will say streamlit.caption. This app helps you predict a restaurant's review. And we can say class. So I say class because we are going to get some stuff like poor, average, good, and very good, and excellent. So at the next step, I'm going to add a divider for it to look better. Now we are going to take our inputs. So what our model takes is, actually we can come back to the X in here and check. So I'm just going to get to the X picking side. We can see average cost for two, has table bookings, has online delivery, and price range. So we will say at the first place, actually I'm going to take it average cost for two. So we will say average cost, and it's going to be streamlit.number input, and let's say please enter the estimated cost for two. Actually we can add average two, and then I'm going to say like minimum value is going to be, let's say 50, and maximum value is going to be like, let's say 99999, it doesn't matter, and let's set the value as 100 1,000 actually is going to be better. And let's add the steps. Step is going to be something like, let's say 200. Okay, great. So then what I'm going to do is, actually we specified them because I don't want anyone to enter 0, and maximum value doesn't matter, and value is going to be start from 1000. Okay, the next step we are going to define the second, and I will say has table booking. Okay, in here I'm going to say like table booking, and it's going to be streamlit.checkbox, and I will say restaurant has table booking, and then what I'm going to do is it's going to return something like yes or no, and I'm going to give values like yes and no. Okay, so and then what I'm going to do is, since this is a checkbox, we are not going to give them, I remember it like select box, we can do both. Let's do select box for one and checkbox for the other. Like we have two this binary ones, so it has online delivery side. Actually, let's make it checkbox too. Okay, so online delivery, and then I'm going to set this like streamlit.selectbox, and then I will say restaurant has online booking question mark, and I'm going to give like, let's say yes. I'm going to open a list, yes and no, just like this. And I'm going to say like the last one, price range. I will say price range is going to be streamlit.selectbox. It's going to be like, what is the price range? 1, cheap, cheapest, 4, most expensive. And I will give the options like 1, 2, 3, 4. Okay, great. We are going to get our number inputs. Let's just firstly save this, and let's make it launch in our browser for checking how it looks right now. I will say streamlit run app.py, and I'm going to change my OBS settings right now. Okay, we got an error, and it says write the set page config at the first site. So I made a mistake on that side. I'm just going to cut this, and then I'm going to get it to here. Then I'm going to save my file, and I'm going to relaunch my Streamlit app. So I will say streamlit run app.py, and now it's going to work smoothly. Yeah, and I'm going to give it to the screen right now. So just like we wanted, it says restaurant rating prediction app. This app helps you to predict a restaurant's review class. We can see we have add decrease options, and we have select boxes in here, like just like in here. Great. Okay, we can go to the VS Code again. So I'm just going to close this one, and I'm going to continue to code. Okay, we get our inputs right now. What we are going to do, we are going to open a button like predict button, and it's going to be streamlit.button predict the review. And then we are going to add a divider again, and now it's on our model side. I'm going to set the model like joblib.load our model name in here. I'm just going to find it real quick, copy, and I'm going to add it in here, and it's going to be our model. I'm going to set it like this, and then what I'm going to do is I'm going to say like at the first place I'm going to change this like booking status, and it's going to be 1 if table booking equals to yes, else 0. So I'm going to do this same for the online delivery. I will say delivery status, and it's going to be 1 if online delivery equals to yes, else 0. I'm just going to make a paste from my notes for you to remember. So I took notes like this in the notebook, so I used them. Okay, 0 is no. So at the next step, I'm going to do the scaling option, like you can see the scaler. What I'm going to do is I'm going to set them like average cost, and it's going to be average cost, actually not scaler that fit transform average cost. And I'm going to do this for all of them like we will say booking status, scalar, fit transform, average cost, and we will say like delivery status, scalar that fit transform, delivery status, and we will say price range, scalar, fit transform, price range. Okay, and then we are going to say if this button applied, if predict button. Let's start by making it snow, like we will say streamlit.snow, and then we are going to say model.predict, and we are going to give a two-dimensional array like this, and then I'm going to say like I'm going to give firstly, let me quickly check the average cost, and then I'm going to give booking status like this, and then I'm going to give delivery status, and I will give price range just like this. And just for checking if it's working, I will say streamlit.write. Let's make this like prediction, and let's check how it looks. I will say prediction, and then I'm going to save this, and I'm going to make my app rerun again, streamlit run app.py, and see you in the Safari side. Actually, before that, let's make a change on here. I will say I'm not going to stop the Streamlit running at the background. I'm going to make a small change in here, like I will say it raised an error because of the shapes. So I will say like I'm going to do. So I just recognized that I didn't transfer the scalar and I used like this. So this is wrong. So what we are going to do is in here we have our scalar and it's fitted. So now I'm going to say like I'm going to get to the last place. I will call the scalar again. It's fitted right now. So I will say joblib.dump, and then I will say scalar, and I'm going to save it like scalar.pickle, and then I'm going to get to my app. I will use this scalar in here. So I will say joblib.load, and I will say scalar.pickle. From now on, I'm ready to use my scalar. And after saving this, I'm going to come back in here, and I will use like, I will delete this. I will say average cost scaled, and it's going to be like scalar.transform, and I will say average cost. And then I'm going to do the same for the others, and then I'm going to come back to here in a second. So let's not do that. So let's delete that because we use the scalar on the 4 features. What I'm going to do is I'm going to say numpy.array, and I'm going to pass in my values like, and we will give in here, I'm going to say like values, and they are going to be such like that. I will say average cost and booking status, delivery status, and I will say price range. After that, I'm going to say numpy array, and I'm going to give like values. So now my x values, we can set it like that. And now I'm going to set the x like is going to be scalar that transform, and then I'm going to say my x values. Great. So in here I'm going to give the x for the model to predict, just like in here, and I'm going to save my file. So we have one final step. I'm going to just delete this extra 2 dimensions since it's already in 2-dimensional place. So now everything is smooth. Okay, actually we need x in here. So everything is smooth right now. We did the operations perfectly and we transferred the scalar. I'm sorry that I forgot this at the first place. Since we trained our scalar at the first place, we are not going to train again. So if you do that, it's going to raise 0 values every time. So in this way, we do everything clearly. Okay, I'm going to summarize to this point, like what we did. We transformed our scalar, we set our page config title, we take the inputs from user, and we set the booking status and delivery status as the thing we wanted, like we want 1 and 0 instead of yes or no. And then we set the values, and then we are going to turn them into 2-dimensional array. Then we used our scalar to scale them, and then we said if the predict button is applied, say streamlit.snow, and we say prediction model.predict and streamlit.write prediction. So I'm going to open my terminal right now, and I will say streamlit run app.py once again. It's going to work smoothly right now, I'm pretty sure. And I want to mention one thing, that if you don't close this from this trash bin, like if you just make it like this and keep coding, you can see the updates when you save the file on the Streamlit page. So when you're developing something on the Streamlit, you don't need to close, open, write streamlit run app.py again, and you can always run it at the background. So let's get back to the Safari. So in here we have our app, our button is on here. So let's just change this like 1.8, and then I'm going to set this to 2, and I will say predict the review. Great, so we have our prediction and everything is working smoothly. So let's just change this and change the values, and let's retry that, and we can see the predicted value in here. Great, now our last job. What we are going to do is we are going to turn these numbers into text values like we had in the ratings side. Like if it's, for example, if it's about 3.5, we are going to write good in here. So let's do that. So there is only a simple part left. What we are going to do right now is I'm just going to make a copy paste from my notes for this video, like just in here. So it says above 2, below 2.5, etc. So let's do that. So we get a float from this. So with this float, what we are going to do is if prediction is less than, let's say 2.5, then streamlit.write poor, and we will say else if prediction is less than 3.5, we want streamlit to write average. And what we are going to do is else if prediction is less than 4, like this, we want it to write good. And as the not the last, else if prediction less than 4.5, then we want very good. And what we want at the end is else streamlit.write excellent, just like this. Okay, everything is ready. I'm just going to delete these comments, and then I'm going to save my file. Since it's running in the background, I'm jumping to the Safari. So this was how we left our file. I'm just going to refresh it, and I'm going to enter 2000, and I'm going to set the price range as 2 and set this as no, and I will say Predictor review, and boom, here is the average, and we can see the raining snow in here. We can just change this answer. You can use it as you wish. You can try 4, you can try different option, no, and you can say, let's say 5000 to here, and you will get very good. And let's say 100, minimum was 50, you will get very good too in these options. Let's say 100,000, very good. So let's say yes in here, good, yes in here, very good, 1, we can get the prediction average. Great, so our app is working smoothly. So what's the output? Let's write a scenario. Let's say like we are going to open a restaurant, and we are going to set our things to optimize the reviews, like we want really good reviews from the customers, and we can just set this up like we are planning an average cost of 1000, and we are not planning table booking, we are not planning online booking, and our price range is going to be 2. So we are going to predict our review, it's average. So we don't want average, we want at least good with the minimum cost to us. So let's say we are going to open online booking for better reviews. Let's see if it works. No, it didn't work, so we don't need that. I'm going to set it to no. Let's say we are going to change the table booking to yes for better reviews. So it's still average. So let's try other options. Like let's try to decrease the price range. And when we do 1, it's average. So maybe the expensive we do, maybe the people more like it. So let's try 3, and it's good right now. Oh, let's see if we can get the very good. So I'm going to say 4, and it's still good. So let's remain it in 3 and let's change other options. Like I'm going to do this, yes, it's still good. I'm going to make this yes too. It's average, so we want no in here. Also we can make it no. So let's change this value like 500 and let's see what we will get. Still good. Let's try 100 and very good. So let's find the number gives the very good with the minimum at the average cost, like 250, 300, actually 400. Let's try that. It's still very good. So 450, very good, and I think 500 we got good. So let's try 475, very good, 480, and it's this. So what we get is we get the very good review estimated with the minimum cost to us. So I think it's great and it's applicable. So let's just recap the code and finish the video. Okay, what we did is let's start by notebook. I'm just trying to set it quickly. Give me a second. Okay, now I'm going to get to the upper side. We did data analysis, then we did feature engineering in here, then we trade the models and we took a model that we liked, and we also took the scaler since it was trained on our data. Then we come to the Streamlit side and we imported Streamlit NumPy for array creation, Streamlit for the entire web app, and we imported scaler. It's not necessary since we transferred our scaler, and then we imported the joblib. So then we set the page config as wide, and then we transferred our scaler. We give our app a title, then we added a caption, and we used divider. And then we just created a number input and select box. These are the user inputs to our model, like here you can see. And then we created a button named as Predictor review, and then we used Streamlit.divider. And then we loaded our model. Then we set the booking status as 1 if the table booking is yes, else no, and we did the same for the delivery status. Then we set our values like this, and we created a 2-dimensional array. Then we used scalar.transform for getting our values scaled, and then we said if the predict button is applied, then Streamlit.snow, the snowing effect that we built in. Then we get the prediction using our X in here with the same format that we trained our model. And then we said if prediction, it returns a float, less than 2.5 poor, less than 3.5 average, less than 4 good, less than 4.5 very good, and else excellent. So that was all for the coding part of this video. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I have a playlist named Data Science Projects where I have more than 20 data science projects with their datasets on that playlist. You can just reach to it from the cards of this video or the link in the description. See you in the next tutorial. Have a great day.